Hey everyone, this is Morgan. So we are going to be looking at pH calculations today. And I refer to this as a square roadmap. It's the relationship between pH, pOH, H+, often called H3O+, and hydroxide ion, OH-. What this tells me is I can convert pH into either pOH or H+, but I cannot convert it directly into OH-. That would be a two-step process. Okay? So I think you get the idea about how this works. So we have a couple relationships that we need to remember. pH plus pOH equals 14, and H plus times OH- is equal to 1.00 times 10 to the negative 14, as long as we're doing all of this at 25 degrees Celsius. Okay? So now, if I know that the pH of a solution is 7, I know its pOH is also 7. That's a neutral solution, by the way. Now, according to the definitions then, H plus is equal to 10 to the negative 7th, and OH minus is equal to 10 to the negative 7th, because the H plus concentration is equal to 10 to the negative pH. Okay. So now, if the pOH is 11, the pH must be 3. So the H plus is 10 to the negative 3, the OH minus is 10 to the negative 11th, and this is something that's acidic, because its pH is less than 7. Now, that's basically just how it works. What about if we're trying to deal with Sig Figs? Notice that this number, 1.00 times 10 to the negative 1, has 3 significant figures. Now, I'd be tempted just to say, well, if it's 10 to the negative 1, take the negative log of that, and the pH is just 1. Except these numbers up here, which if you remember were called the Mantissa, they are the numbers that represent the measurement in what's going on in this solution. And the times 10 to the negative 11th, that just indicates the magnitude. So if this has 3 Sig Figs, I'm going to need to put 3 zeros after the decimal point. When you write a pH or a pOH, the number of places after the decimal will equal the number of significant digits in the measurement. See, that 1 is just holding magnitude, kind of like the 10 to the negative 1. In fact, that and the 10 to the negative 1 are kind of equivalent to each other. All right, so that means the pOH must be 13.000, or the OH minus is 1.00 times 10 to the negative 13th. Now that's a number I could get by saying that the OH minus is equal to 1.00 times 10 to the negative 14th divided by the H plus, which is 1.00 times 10 to the negative 1, and this equals 1.00 times 10 to the negative 13th. All right. By the way, this one's also acidic. Now, since that's 1.00 times 10 to the negative 12th, I can get 1.00 times 10 to the negative, that's negative 12th because that's negative 2. I think I misspoke there. Let's look at a calculator. Let's see if we can do that now. Okay? 1.00 second EE negative 14. That's my value of kW. Divide that by 1.00 second EE negative 12. Boom. And I get 1 times 10 to the negative 12. I think I said 12 again there. I meant to say 2. Okay. So that means the pH here is going to be the negative log of that number. Well, let's take that. Negative log. And make sure you use the negative sign and not the subtract sign. And then I'm going to put the answer from before. Boom. And I get 12. But I have to say it is 12.000 because of the 3 Sig Figs. This is 2.000 because these two add up to be 14. And this is basic. Okay. Now those are the ones that you can do in your head. But what about when we get like 2.00 times 10 to the negative 8th? Well, what I'll do is take the negative log of 2.00 second EE negative 8th, and I get 7.699. And then that's, rounded off for Sig Figs, 14 minus 7.699, and I get 6.301. Now, I can get the hydroxide two different ways. One thing I can do is I can say the concentration of hydroxide is equal to 10 to the negative 6.301, which equals, I'll do that. Second, 10 to the x, negative 6.301, and I get 5.00 times 10 to the negative 7th. Or, let's do it a different way. Let's say 1.00 times 10 to the negative 14th divided by 2.00 times 10 to the negative 8th equals. Okay, so now 1.00 second EE negative 14th divided by 2.00 second EE negative 8. Boom. Hey, 5 times 10 to the negative 7th. I'm getting the same answer either way. By the way, this is a basic. 7.500 means this is 6.500. So 10 to the negative 6.500 will give me the pH. So second 10 to the x, negative 6.500, and I get 3.16 times 10 to the negative 7th. And then second 10 to the x, negative 7.500, and I get 3.16 times 10 to the negative 8th. And this is acidic. We're going to be doing a lot of this. So to find the pOH, I can subtract that from 14. So 14 minus 4.320, and I get 9.680. Then to get my my H plus concentration, second, 10 to the x, negative 4.320, and I'm getting 4.79 times 10 to the negative 5th. And then for the OH minus, second, 10 to the x, negative 9.680. And I'm getting 2.09 times 10 to the negative 10th. Now just for kicks, what I'm going to do is multiply those two numbers together. So I've got that one multiplied by 4.79 second EE negative 5, boom. And I'm getting 1.00 times 10 to the negative 14th. It has worked out. Yay. All right, so if that's 0.90, this is 13.10, which means second 10 to the x negative 13.10, and I get 7.94 times 10 to the negative 14th. Then I'm going to do this one using kW. 1.00 second EE negative 14th divided by that answer, and I get 0.125 or 1.2, let's call it 1.26 times 10 to the negative 1. You don't have to put it in scientific notation. By the way, this one was an acid and this one was basic. Now this is 1.00 times 10 to the negative 14th. It turns out the hydroxide is 1.00 because those two have to equal that number. So you've got to multiply by 1. That means the pH is 14.000 and this is 0.000, and this is very, very basic. Okay. Now, if I have a hydroxide here, 9.87 times 10 to the negative fifth. Negative log 9.87 second EE negative fifth. Boom. I'm getting 4.01. We'll call that 4.01, which means this will be 9.99 basically. 14 minus 4.01, yeah. You know, I did divide it by 14 minus 4.01, 9.99. Okay, so now to find that, I'll do second, 10 to the x, negative 9.99, and I get 1.02 times 10 to the negative 10th. And this one would be basic. All right, so this is going to require quite a bit of calculator practice on your part. We'll give you a few homeworks on it. Hope this has helped. Thanks for tuning in. This is Morgan signing off.